Hello and welcome to Techweek TV 2021 interview series. I'm Ryan Ashton, your host, and I'm joined by a special guest, Derek Manson from FI Innovations from Invercargill, all places, which will be part of our discussion, I'm sure, as we delve into this story, which I already know is going to be quite enthralling. So let's start with asking you to introduce yourself and give us some context of your background in the tech space that we're about to embark on, which if I just say 3D printing, and you can give all the detail from here on in. So over to you, Derek.
Yes, my role here is the Advanced Manufacturing Manager at FI Innovations, as said down here in Invercargill and Southland. My background goes back to a more traditional base. Did my time as a fitter welder down at the aluminium smelter down here. Upon completing that, actually went up to Dunedin and completed my product design degree. Whilst doing that, up there, I gave them my first introduction with tech, so coming out of the manual world, moving opened me up to an introduction to 3D printing. That's where my interest was sparked. Completed my degree, went off to work for a design consultancy for a little bit, and then in 2006, set up a 3D printing and product development bureau in Invercargill. Again, the absolute hotbed of technology in New Zealand.
It is.
So yeah, did that for 10 odd years. We're sort of just a wee bit too quick out the gate, so it proved not to be as feasible. Moved on to a couple of design roles, design manager roles and ops manager roles, and then 18 months ago or so, come on board here at FI. When they invested in some new 3D printing gear. So yeah.
Wow. So that's an interesting story, because that's essentially retraining from fitter turner welder into using, I guess, the technology. And in some ways, there's similarities between the work that you do as a fitter turner welder in terms of creating the outcome to 3D printing, but vastly different technologies. So fascinating journey. Thank you for sharing that. That covers also what your pathway is into tech. And I guess if we look at what you're doing now, I know that there's things you can talk about and can't talk about, secret sauce and all, secret Swede sauce. But if you can share a little bit about the sorts of projects you're involved in a way that is okay to talk about.
Yeah, certainly. So we get involved in a few ways, and the simplest way is just files being sent to us, and we're just taking those from the digital, printing them into the physical, and then returning them back to the customer. There's some interaction about feasibility and best practice and what have you, and so that's a lot of what we do. But there's also the other side of working in much closer with most manufacturing companies, whether it be aerospace or a medical device or hardware, whatever it is, but working much closer with their design teams early on to really exploit the benefits of 3D printing or additive manufacturing, as we prefer to call it, and then again the physical printing of those parts, whether it be prototyping or manufacturing.
Yeah. So when you're 3D printing, do they need to design things in a slightly different way at times to be a better outcome from 3D printing than if it was being made by the traditional methods?
Yeah, dead right. So there's some real little tricks or some features of 3D printing that can be really exploited. And one of the main ones, if you imagine at the end of the day, a part lives in space on the XYZ axis. We actually almost don't care what makes up that XYZ. So it can be the part can be as complicated as you like, because everything's being made without tooling or machining or whatever. The geometry can be as complicated as you like. So the part itself is pretty much the same price, whether it's a rectangular block or whether it's a rectangular form that's got heaps of lattice work and all sorts of real intricate sort of features in it. So it's there's a bit of understanding around that to really exploit the tech. Yeah.
So if we look in the background there, I think it almost looks like an axe, some sort of 3D star, and of course maybe a V8 engine. What are those some of the samples or Friday afternoon agile iterations? Tell us about give us a bit of a rundown of those.
the white star that you see, that's soon to be the center of my light in my living room. So we just built a house not long ago, so that's going to be the light. It's going to be hanging down from there. Not finished.
Nice.
My wife keeps reminding me. Yeah. Also in the background, so then you've got the motor that you see back there. So that's a single print that was used for as a jig, obviously in the automotive industry for custom automotive high-end motorsport. And so that's been printed so the rest of the car can be bolted up around it while the actual engine was in development. Other parts that we have, so that's sort of your prototyping sort of stuff. And then there's other parts that we do in the in the thousands for actual manufacturing sort of stuff as well.
Oh, wow. So give us some idea of the scope. Like, I'm instantly thinking of some big factory with all these machines going ching, 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 which will actually be 3D printers rather than, metal presses and things like that. But what sort of size and scale is the space and environment? How many machines, if it's okay to ask?
So we've sort of got 3 different technologies that we use here. 2 are resin-based, the other is a nylon powder-based. They all either work with a laser or at least a UV curing process. Typically what's happening with one machine, and I'll touch on manufacturing, and that's sort of where we see the future in 3D printing or additive manufacturing going. What it means is that you've got a chamber that's around about a 400 square. It's a little bit bigger than that, but approximately 400 square. Within that part and the parts that we're normally dealing with, on average, we're making sort of 300 or 400 parts per build. They all live within that 400 square, whatever rotation, or as long as they're just separated very slightly from each other, we can pretty much cram it in as much as possible. The whole build's cut into cross sections. The laser comes through, does its thing, draws each cross section over time, builds up the whole build, and then you pop out 300 or 400 parts with no molds, tooling, machining, or what have you. So that's on the SLS one, and then the other technologies are similar. Our biggest machine is about a 750Q, and in 3D printing, that's quite sizable. There starts to be quite a curve on cost, and as you get bigger, the costs at the moment, unfortunately, do go up a wee bit. But for your smaller, everyday sort of cell phone side stuff, it's becoming very economic.
Wow. So when you talk about the 400 or 750 cube area, and it'll print all the parts that you can cram into it, are they sort of, I'm just thinking of, here's one of 300 parts that make up this block. Do they get printed connected together some way, or they produced as a single item on the production run?
750, it sort of lives on its own footprint, if you will, and anything above it, we can put parts on top, but it has to be physically connected through a separate structure, but it also prints that structure. On the other one, the SLS, because it's the powder-based one, any gaps or whatever just fills up with powder that the laser doesn't touch, so it just stays a nice loose powder. So there's no extra support needed. Everything's just living within. So when the build's finished, it's just this great big rectangle of powder. Within it, you can't see them. There's parts that have been hit by the laser have been made solid. The parts that have been left alone are just loose powder, and then you basically just shake it all apart in essence, and there's your parts.
And basically all the parts come down, and the powder that's not part of a part floats away, or you capture it, but
it goes back in the system and gets ready. Yeah.
I had no idea. I still have this sort of
the old glue gun. Yeah.
Yes, that concept in my mind. So now I understand how it actually works. It now gives me a really good appreciation of how that's possible, and now got me thinking. Just thinking about some of the aspects you've talked about, being fit to turn a welder, retraining, doing product design, and then you were talking about the what I guess would fit into your operations background. So the design aspect's quite obvious. How do we design stuff to be optimized for 3D printing? The operations is, how do we make it cost effective? What are some of the other areas that I haven't picked up on that are worth sharing? Imagine you're talking to a classroom of kids, and they're now starting to twig and go, wow, imagine what we could make if we did this. What else do they need to know?
all they need to know is sort of just that point I said before, that the geometry, it's one of the few technologies that we're absolutely geometry free. So as far as constraints are concerned. So basically, if you can create the 3D file, and that's probably the Achilles, not the Achilles heel, but the one limitation. Anything we do, we have to have a 3D file, and that can be scanned or CADed or downloaded or whatever. As long as you have a 3D file, that geometry can be created. So when you start talking about, and we mentioned about the medical industry, for instance, so you start talking about bone structures and stuff like that, it's absolutely no, you can just print it. So it means that they can see a lot of our training as product designers is about the constraints of the manufacturing processes. So if something's being injection molded, it has to be able to be released from a mold. If it's a fabrication thing, it has to be able to be folded and cut, and there's limitations around that. It really starts to just free the mind about the actual solution rather than the process. So it just sort of unlocks it. And it's not that it lessens the skill, because your design skills, because you're then really trying to solve the design problem rather than the manufacturing problem.
I'd almost say it enhances the design capability. And I'll use a really basic example for people to understand this. I used to be a art director, and I'd use all the Photoshops and different software. Now I'm not. That was 20 years ago, but I do a lot of design work using PowerPoint.
Yep.
PowerPoint compared to Photoshop's way limited, but I still work out how I can create a really nice design and effect from a graphic point of view for presentations and adverts and stuff using that limitation. So that's, I think, a nice way, a simple way of people understanding that. So what does it cost to, say, make an engine? Or what can you give us? You can use any example, but give us some sort of context of if you've got to go and buy the materials, or you wanted to, say I wanted to, I don't know, print a whole range of, I don't know, statues.
Yep. So everything ties back to volume and machine time. So obviously the bigger the part, the more material it uses, the longer it takes to print, the dearer it is. But at smaller parts, if we're talking about, little USB sort of stuff, a print like that, the part might be $10 in a production sort of scenario. Engine block in behind, all of a sudden that's thousands and thousands of dollars. So and anywhere in between. There's a few wee tricks about, I talk about the volume. Now, if you've got, like, you're printing a vase or something like that, there's a big volume in the inside, put parts inside it. So, again, it's not just the X, Y, Z of that part. It's, and so you can do little tricks like that as well to help economize your printing. Yeah.
But don't put a part that sits in the bulb that can't get through the neck.
Oh, we would never do that.
I probably would. That's what I thought of it. So what is Techweek to you, and what is Techweek to Invercargill? I mentioned earlier that I'm from Dunedin, sitting in Auckland at the moment, but I have a bit of context of Invercargill, spend a lot of time down there playing sports, and as you mentioned, or sort of joked at the beginning, what your business does is exactly what you'd expect to find in the tech hub of Invercargill. So I think of Invercargill probably very agriculturally, but this is extremely technical. So what does Techweek mean to Invercargill? What's happening down there? What's the buzz?
Yeah, well, like down here, there's we're probably just a wee bit more reserved about telling our stories. Is probably, so we're our own worst enemies from that point of view. But you scratch the surface a wee bit down here, and there's a fair bit going on. So with our primary industry, some stuff down here with forestry and meatworks and all that, there's a lot of secondary research that goes on with that. And there's a lot of R&D that goes along with it as well. Our, again, industry with aluminium smelters and what have you, they've had well-documented battles the last wee while, but inside that is an outfit that's doing a lot of automation, and there's a lot of R&D smarts going into that. And as a result, all the supporting companies and tradesmen and all that are getting upskilled from that point of view. We have a lot of aluminium boat building, with Stablecraft being based down here. They've just won an international design award, which is just a massive deal. So so that again, that's happening down here with quite a big staff and design staff and R&D going on. So for us, Techweek's probably it's awareness, but it's probably also about just how everybody connects and communicates and say, yep, we're based in Invercargill. 95% of our customers are New Zealand wide. Overnight couriers go everywhere. The files come in digitally. So quite frankly, it doesn't matter where we are. Yeah.
Well, there's a good point. I just didn't think of that, but the amount of couriers in transport, depending on, might be, truck size, van size, whatever, but there's probably a reasonable amount of transport and courier popping in and out of your organisation to take stuff back all around the country. What's your sort of mix between New Zealand and global? Is there an element of global?
We're fully domestic.
Okay.
And we've noticed since COVID as well, there's been a real desire for people to, so if they were getting stuff done in Asia or somewhere else, they actually want to pull it back. Because those, we're just talking about couriers and freight, all those supply chains are pretty disrupted at the moment. But they can only pull back to New Zealand what's available here. Yeah. So with us coming along and we've invested heavily in some pretty new and impressive machinery. So that's now a resource available. So yes, now they can pull it back. So it's a bit of a two-edged thing. You can't bring everything back. But what they can, they've been pretty keen to just to make
so you may not want to answer this, is okay, but if you can, in terms of the amount of spend on the machinery, etc., taking you've invested more so with COVID recently, are you able to give us some sort of picture of that investment, and is that sort of bootstrap, generated by the company's revenue, or is that working with some of the New Zealand agencies like Callahan Innovation, or how does it all come about?
Bit of everything, a bit of all of that. So the first machine actually came about from the PGF initiative that was running, the Provincial Growth Fund. FI was one of the first companies to be involved with that down here. So that sort of funded 50% of the first machine, the SLS. Now that's a machine that's retailing for $600,000-700,000. So it's not that it stopped that purchase happening or not happening. It just meant there was a little bit of risk taken out.
So sounds like some fantastic developments, and I'd really love to get down there and see it in action. I don't know if we can actually come and see it in action, but it leads me to think with the last question for you. What do you think is New Zealand's biggest tech opportunity?
For a start, you're always welcome. Everybody's welcome to Southland. It's no problem at all. I think Tech New Zealand, I think we're really, really good. Being so small, we're very good at collaboration. We've got a lot of smarts here. So you just got to look around what's happening with aerospace, what's happening with, and obviously with what Rocket Labs and others are doing. You just got to look at what F&P Healthcare are doing. It's that niche opportunity. It's executing it really, really well, using intelligence to do it, and then chucking some tech in to give us that competitive advantage back against labour rates and what have you as well. So, embracing automation in niche manufacturing, and then in high value industries like the aerospace and all that. And we were talking before, with entertainment and movies and stuff as well. Those sort of industries are just I think they're for the taking for New Zealand.
Awesome. Well, thank you so much for your time, Derek, and pleasure to learn all about 3D printing and what you're doing down there in Invercargill. We're now, really putting Invercargill on the technology map with some of the stuff that you're doing, achieving, talking about. Sorry, not we, you and the team are. So congratulations is what I want to say. Thank you very much for your time, and it's been a pleasure getting to know all about you and your business.
Pleasure. Thank you very much.
Cheers. See you later.